So we want to try and solve this. And unlike the problems we looked at in section 7.1, we wanted to have just sines or just cosines. And sometimes we could use a square to switch them, but there's no squares here. So compared to the equations that we were trying to solve in the last section, none of those tricks apply here. What I do have for a trick, though, is that the formula for that wave shift I was talking about. So a times the sine of x plus, let's call it phi, can be rewritten as some number m times the sine of x plus some number n times the cosine of x. And what I have here is I have my m and my n. So what we're going to do is we're going to reverse engineer to figure out what a and phi are. And then we should be able to solve this. So to do that, we applied the angle sum formula for that. That was our first step. So angle sum formula says that top thing is going to be equal to a times the sine of x cosine of phi plus a times the cosine of x sine of phi. And in this case here, the a and the cosine phi are constant. Since there's a sine here and a sine there, then they have to equal -6. And then the a and the sine of phi are constant in this part. Oops, I want a different color there. Let's try green, maybe. A, there we go. And the sine of phi are constant, so that has to match this 2 here because they both have a cosine x in it. So that was our second step in doing this. So a cosine of phi has to equal -6. And then a sine of phi has to equal 2. And the next step is we apply the Pythagorean theorem to this here. So we moved the a over to the other side before. Cosine of phi equals -6 over a. Sine of phi equals 2 over a. And we know that actually let's write a cosine first, since that's the order I have them here. Pythagorean theorem says cosine squared plus sine squared has to equal 1. Cosine is -6 over a, so we're going to have to square that. Sine is 2 over a, so we square that. We can multiply the a squared up to the other side. So -6 squared is 36. 2 squared is 4. That's going to have to equal a squared. 36 and 4 is 40. So a is going to be the square root of 40. Let's see, that's 4 times 10. So we could say that's twice the square root of 10, for whatever that's worth. So that's our a. And then our phi we get by using either one of these right here. So I usually use the cosine one. So I get cosine of phi. So let's head this way. Is equal to -6 over twice the square root of 10. So it cleans up a little bit. That's -3 over square root of 10. And so that phi has to be the arc cosine of that. And I'm just kind of stuck with that. There's not much I can do with that. That's not any special value I remember from the unit circle. So it's just, that's it right there. So what have we figured out? We were able to rewrite this because we found a value for a and a value for phi. So we now know that a, twice the square root of 10, times the sine of x plus my arc cosine here -3 over the square root of 10. That's all inside there. That has to equal 3. And so then I can solve this. So we had to first rewrite. That's a bit of work, but we can solve now. Divide 2 square root of 10, oops, to the other side. That gives me the sine of x plus the arc cosine. Is equal to 3 over twice the square root of 10. Arc sine gets rid of the sine, so x plus the arc cosine equals the arc sine, or sine inverse if you like, of 3 over twice square root of 10. And I don't think it's worth rationalizing the denominator here. And then we can subtract that arc cosine over, so we get one answer. Let's see, we have the arc sine minus the arc cosine. So let's test that and then find another one. Minus arc cosine. Okay, let's make sure I didn't miscopy anything. 2 square root of 10. Oops. Nope, that's right. I think that looks right. Let's test it. So let's see, I'm going to bring my Desmos down here so I can see and type at the same time. I'll be right back with that. Desmos graphing calculator. So I think I'm going to call this solution A is the arc cosine. And again, I'll show this in just a sec. No, arc sine is the first one. Of 3 over 2 square roots of 10. And then minus arc cosine. And that one is -3 over the square root of 10. All right, so I'm getting about -2. Just look one more time, make sure I typed it right. That does look correct. All right. So I was calling it A, so I can reuse it. Arc sine of 3 over twice the square root of 10 minus arc cosine of -3 over the square root of 10. I get -2.33. Thinking about, let's test that and then we'll go for another solution. So to test that, I want to compare that to the original function, -6 sine plus 2 cosine. So -6 sine of x plus 2 cosine of x. And let's call that f of x. And I believe if I plug in this value I calculated A, I should get 3 as the answer. So what is f of my calculated number A? It comes out to 3. So I did get one of those values. Let's think about how to get the other one. So looking back at my work here, let's see, we have a sine of x and a cosine of x. So thinking about the period of this for a moment, both of those have a period of 2 pi. We rewrote it as just a sine function, and that's a 1 times x, so the period is still 2 pi. And when we're looking at solutions for sine, once we find one solution, like let's just suppose that we found a solution over here, sine on the unit circle is a y value, remember, So the other solution is always pi minus whatever your first solution is. Now, let's see. Give your answers actually 2 decimal places separate. Okay, we want the first 2 positive solutions. All right, so let's see. I think mine was negative. So let's look back here. Yeah, I got a negative radian value. And so I want the positive version. So I would have to add 2 pi to that to get the positive version. So again, that's the first solution according to the arc sine and the arc cosine, but it's not the first positive solution. So the solution I want, I guess I'll call that one B, would be that one plus 2 pi. So that should be the first positive one. And then, or maybe not, let's see, the other solution is pi minus that. Let's see what that one looks like. Let's call this one C. So anytime we're working with just a straight sine period of 2, the other solution was always pi minus the first one we find. So pi minus A gives me 5. Okay, yeah, so that one is bigger. So the first positive solution should be 3.96. Second one should be 5.47. And then we should just double check just to make sure with our function f of b should be 3, and it is. And f of c should also, oh, I got a mistake there. Why didn't that one work out? Interesting. Okay, so what is wrong with my logic on that one? Oh, the shift throws that off, doesn't it? No, we should still be okay with a shift. No, the shift throws it off, I see. All right, I'll explain. New page. So I had the sine of x plus, let's just call it phi instead of the arc cosine. And my claim was that was equal to 3 over 2 square root of 10. 3 over 2 square root of 10. The next step here is to apply the arc sine. So that's going to give me x plus phi stays on that side. And the other side, I get the arc sine of 3 over 2 square root of 10. And it's at this point here, so that's the first solution from the arc sine. The other solution is going to be pi minus the arc sine. So I did have my order of operations wrong there. And then the shift threw it off. So one solution is x plus phi equals arc sine. The other solution is x plus phi is equal to pi minus the arc sine. And then I can subtract over theta. So the other solution should be pi minus the arc sine like I have here. 3 over 2 square root of 10. And then subtract over that phi, and that phi was the arc cosine of negative 3 over the square root of 10. Yeah, so I had the order of operations there wrong. It's a good thing I checked. So that my original idea for C didn't work there. So let's see, how do I want to do that? I have to just totally recalculate it. I want pi minus the arc sine first, like I have above here. And then I can subtract that value of phi, which was the arc cosine. All right, so that should be the other solution. And it's negative, so we would have to add 2 pi to that to move it into the positive range. Pi. So let's check that number. What is f of that number? There we have the 3. Okay, so my two solutions are the first one is the 3.96, and the second one is the 6.11 to 2 decimal places. So that one was a lot trickier.